Alright, so we're going to basically look now at the modified internal rate of return that we actually talked about in the lecture that you should have read or listened to. What we're going to do is a problem. Let's lay this problem out. We're going to run for 7 years. We have initial outlay of $4 million. We have year 1, $3.5 million, which is good, which is a benefit to us. $2.5 million, $1.5 million, $500,000. Then we all have a cost of $500,000 and a cost of $1.5 million and a cost of $2.5 million that we have. Now, since we're doing this, we're doing the MIR, and we need two rates, don't we? We need a borrowing rate or lending rate, and let's just say that is 8%, okay? And then we have an investment rate, and that is at 15%. Now, the key thing here also is that your borrowing rate, if your borrowing rate is ever bigger than your investment rate, you're in trouble, because that means you're actually borrowing money at a higher rate than you're actually getting for it if you invest it. So you should have some kind of relationship, maybe not as large a span of 7%, but you should have the borrowing rate should be lower than investment rate for it. So the very first thing we actually do is, remember, we go to each time period and we make sure that there is only one either a cost or a benefit, or in this case they used expenses or receipts for it. So what we want to do is let's look at the expenses or the costs. So these are the expenses or the costs for it. And what we want to do with all the expenses or costs, we want to move them to the present. We're going to move all of these, since the $4 million is already at present, we don't have to do anything for it, but the $500,000 we have to move it to the present, the 1.5 we have to move, and the 2.5 we have to move to the present. So what we want to do is we want to get the present worth of the expenses, or in this case the costs. It's going to be equal to the $4 million plus the $500,000, and we're going to find a P given an F, and the interest rate. The interest rate we're going to be associated with the expenses is the interest rate of the borrowing or lending rate, which is 8%. So make sure that you don't get confused on which one to actually place here. Since it is 5 time periods away, we want to move it 5 periods, and then we do the same thing for the $1.5 million. We're going to find a P given an F at 8%, and that's going to go for 6 years. And then we have the $2.5 million, and we're going to find a P given an F at 8% going for the 7. And what we actually can calculate up, we find the net present worth is somewhere around $6.744 million. Okay, so to recap, what we do for each time period, we either get a benefit or receipt, which means a benefit or receipt, or a cost or expense. So in this case, you can see here, these are our benefits or receipts, the positive numbers, and our costs or expenses are the negative numbers that go below the line. We then take and bring all of the expenses or costs, we bring them to the present, and like we've done here before. Now, what we do with the receipts or the benefits, we want to take these receipts and benefits and move them to the future, and we're going to move them to time period 7. So in this case, what we have is that we have something that looks like this, and this is just one way of actually doing it, where you can take the 3.5 million. Notice we have a series here. We can say it's 3.5, and we have a gradient that's minus. It's a $1 million gradient going this way, but it's rather easy to move this to this time period 0. So what we could do is we could move everything to time period 0 and then move it into the future very easily. So we have the gradient, or the annual, so we're going to find a P given an A. Now the interest rate we're going to be using is not the borrowing rate, it's the investment rate that we have here. So it's the 15%. So be clear on which one you're actually doing. And we're going to move it for time period 4, since there's 4 in this series. So we have 4. That will move all of this $3.5 million here, which would go this way. It is going to move to the time period. But we have to subtract off our gradient, which is the 1 million that we actually have, and we're going to find a P given a G, the gradient, and it's going to get at the same interest rate or the investment rate of 15%, and it also runs for the same time period, which is 4. So that means we have now compensated and moved everything to here, but we're not moving it to the present value. Only expenses or the costs are in the present value. We want to move this to the future. So what we want to do is that we have to take this and move this forward into the future by using to find an F given a P, again using the same interest rate of 15% for the investment, and we're moving it 7 periods forward. So once we do that, we find out this is equivalent to $16.509 million. Now, the next thing what we want to do is that we want to set the present worth of the expenses or the costs. We need to set that equal to the future worths of the receipts and see how they compare to each other. So the way we actually do that, we want to move the expenses into the future. So I should say this should be expenses. We want to move them into the future. So what we want to do is that we're going to find an F given a P at some kind of interest rate for 7 years, and then it's going to also be equal to the receipts at that point. So what we want to do first of all is move the present worth of the expenses or costs. We want to move them into the future, and so we can do a comparison one-to-one with the receipts in the future. So the way we actually do that is the formula. So we take our number, the 6.744 million, and we find an F given a P at some kind of I for 7, and let's set that equal to the 16.9 million in that. And so what we find is that the FP, I percent 7, is equal to 2.448. We find then at that point that the I is equal to, let's say, if we take an I at 12%, we find that that FP 12% 7 is equal to 2.211, and we say an I of 15% FP 15% 7 is equal to 2.660, and we have framed our number. And when we do our interpolation, we find out our interpolation gets us around 13.58% for it. Now, I think the exact answer is somewhere around 13.64% or something like that, and you can see we're a little bit off. If we notice that we had a broad range between 3%. We didn't frame it as well as we can, and if you had framed it, using the number, say, at I equals 8%, then that would have equaled 1.714, and using the same 15%, 2.660, we would have come up with linear interpolation. We would come up with a number of 13.43%. Now that is a little bit too large. You notice that compared to 1.6 for something is basically too large, while this one is more than a tenth off. This one right here is less than a tenth off. So what we want to do is, this was almost 2/10, I believe, being incorrect. So this would actually be considered a wrong answer for it, while this one would be right. So make sure that you frame it. It doesn't have to be exactly framed, but don't get a very large frame like that, where you have like a large span for doing it for the problem. All right.